Hello everyone. In this video, we will discuss about odds and probability. And basically, we'll define what is the odds ratio. So this is the very important. Before coming the odds, we need to understand what is the probability. As we know, probability of outcome is with outcome divided by with and without outcome. Are, as we know, according to definition of the probabilities, total number of favorable cases divided by total number of exhaustive cases. Or other way we can say, once we are tossing a coin, what is the probability of getting the head? So it would be head would be 1 and total exhaustive number divided by in denominator would be head and tail, it would be 2, so that means it would be 1 by 2. Now we need to understand what is the odds of outcome. So odds of outcome is the with outcome and without outcome. So this is the basic difference. We need to understand probability of outcome with outcome divided by with and without outcome, but odds of outcome with outcome divided by without outcome. Now we need to understand what is the odds. This is the very important. So we'll discuss it with an example. What is the odds? Let's say that probability of success is 0.8. So probability of success is 0.8. So we can say P equal to 0.8. Now, then the probability of failure is according to definition P equal to 1. 1 minus P equal to Q. So this is the 0.2 is the probability of failure. So we have probability of success and probability of failure. Now, odds of success. Odds of success is P by Q. So probability of P is 0.8, Q is 0.2 equal to 4. So odds of success are 4. And then what is the odds of failure would be Q by P 0.2 divided by 0.8 equal to 0.25. So we have odds of success and odds of failure is 0.25. Now we need to understand what is the odds ratio. So odds of success, odds of failure. As we know, according to definition of the ratio is one quantity divided by another quantity, that is the ratio. So odds ratio is odds of success divided by odds of failure. So we have a value of the odds of success is 4 and odds of failure is 0.25. So once we solve this numerator divided by denominator, it would be 16. Now important point, we need to understand, we need to interpret what is the meaning of 16. That is the important role of the researchers. Odds ratio, this is the simple mathematical, it's a simple person can do it, but important role is to define, interpret 16. So meaning of 16 is the odds of success are 16 times greater than for failure. Means once we are going to perform any experiments, so there is chance 16 times success would be greater than in comparison to failure. This is the meaning of the odds ratio. Now we need to understand odds ratio. If we have two dichotomous random variable means binary. Suppose for example we are talking about gender, so gender would be male or female. This is known as the dichotomous random variable and represents a disease and an exposure. So if we have two dichotomous random variable that represents a disease and exposures, one group of the persons, out of them some of the exposed and unexposed, and those are exposed, how many are suffering with the disease, and those are unexposed, how many are suffering the with not disease. This is the meaning of the disease and exposure. So how we'll define the odds ratio with help of the previous equations. As so we can define odds ratio defined as the odds in favor of disease among exposed individuals divided by the odds in favor of disease among unexposed. This is the simple definitions we need to understand about the odds ratio. Now suppose we have a data which consists of sample of n individuals and arranged in the 2x2 contingency table. So 2x2 contingency table, suppose this is the 2x2 contingency tables, means we have a two variables and two categorical variables, and each have a dichotomous response, like some group of the persons, some of the exposed and some of the unexposed, and out of them some of the diseased and some of the some of have no disease, any kind of the disease. So we presenting it A B C D like this, and total number of persons in a community in a group is the n number. Now we are going to calculate probability of diseased among exposed. So this is the exposed group. What is the probability of disease among exposed group? So it would be the A divided by A plus C, probability of disease among exposed group. Now another probability of disease among unexposed group. So this is the unexposed group, and probability of disease and total unexposed is the B plus D. So it would be the B divided by B plus D. Now, so this equation we are going to solve how we'll get the odds ratio with help of this contingency table. Now just we are going to subtract 1 minus P, means as we know P and Q, probability of success and probability of failure. So we need to understand probability. 1 minus probability of disease among exposed, 1. So already this one we have calculated. So it would be C divided by A plus C. Now 1 minus probability of disease among unexposed group, 1 minus B plus BD. So this is the equations. Now we need to solve. So we have a Bayes theorem. As we know, the in statistics there is the Bayes theorem. We need to follow that Bayes theorem. With help of that we can calculate the odds ratio. But this is the formula: probability of disease among exposed divided by 1 minus probability of disease among unexposed, and probability of disease among exposed, and 1 minus probability of disease among exposed. So these alternatively, means other way we can define the odds ratio as the odds of exposure among diseased individuals divided by the odds of exposure among the non-disease. And previously we are talking about the odds in favor of disease among exposure and divided by odds of disease among unexposed. So this is alternatively we can solve it. Now odds ratio we can calculate it on other way: probability of exposure among disease divided by 1 minus probability of exposure among non-disease, and divided by probability of exposure among non-disease, and divided by 1 minus P exposure among non-disease. So we need to put the using equation number previous slide 1, 2 and 3. We can express an estimator of odds ratio. So we have to put all the values as previous slide we have calculated, and we can find out A divided by C, B divided by D, and other way we can find out. This is the mathematically in 2x2 contingency table we can say odds ratio equal to AD divided by BC. It's a cross product of the 2x2 contingency table. Now important points we need to interpret the odds ratio. So odds ratio cannot be negative and it can range from 0 to infinity. And if odds ratio, if we are calculating the problem and getting the odds ratio greater than 1, so exposure is said to be a risk factor for the disease. And if odds ratio less than 1, then exposure is said to be a protective factor for the disease. And if odds ratio equal to 1, exposure has no association with the disease. So this is the simple information, basic information about the odds ratio. What is the odds? We need to understand what is the odds, how we'll define the odds, and what is the odds, what is the ratio, then what is the odds ratio, and how we'll get the mathematically, and what is the interpretation of the odds ratio. This is the important points we need to understand about the odds ratio. So this is the basic things. Once we are going to apply the categorical data, so we need to understand categorical data. It's dichotomous, it's a binary process, and we can interpret it. So this is about odds ratio. Thank you everyone.